Okay, so in this problem, again, we have light coming down. It's going to reflect at one boundary. We have light coming down. It's going to reflect at a second boundary. We want to see what happens when they both come together into my eyes. So maybe the question might be something like this. What is the minimum thickness for both constructive interference and let's start with a lambda of 600. Anyone know what color that is? Red. Pretty close to orange, you're right, it's pretty close. Okay, so we'll say it's red light coming down and up. So in other words, if I look at it, if I want to see red, that would be constructive. If I look at it and I want to see nothing, black, that would be destructive. Alright, let's go through the steps that we're going to use. So the first thing we're going to do is find lambda in the film. So this is a procedure that we did a long time, or not a long time, last unit. Okay, not that long, seems like a long time. Find lambda in the film. Okay, so here's the procedure. It's kind of a three-step procedure. First of all, what happens to the velocity in the film? Slows down. So the first thing you're going to want to do is find the velocity in the film. Anyone remember the equation for that? C over N. Good. Okay, help me out here. I know it's 1 point something. Okay, great. So we found the velocity in the film. Then what we want to do is, well, ultimately we want to know the frequency in the, the wavelength in the film. To know the wavelength in the film, what else do we have to know? Frequency in the film. How do we get the frequency in the film? Well, we know the frequency of the film is constant, right? So if we find the frequency in air, we know the frequency in the film. So that's what we're going to do. Let's find the frequency in air. So we'll go V air equals F air lambda air and lambda air as given, right? 600. So what do you get for F air? Something times 10 to the 14? 5 exactly? Oh, I messed up, didn't I? Always on the recordings. So the velocity in air is 3 times 10 to the 8th. And actually, I just made the biggest mistake that people make, is what I just did. So you can't mix and match those. So 3 times 10 to the 8th, right? And now we're going to say, alright, so F air is equal to F film. And finally we're going to go V film equals F film times lambda film. And now we're going to find. So now we're going to plug in the V film. 1.67, 10 to the 8th. F film is 5 times 10 to the 14th. What do you get for lambda film? $300 something? 334 nano. You could also write 3.34 times 10 to the negative 7 is probably what you got meters. Okay, one of the things I would encourage some of you to do, we have 1, 2, 3, 4 equations we just used. I would encourage you maybe tonight to go home and try to combine these all together, and you should end up with a nice equation that helps you find the lambda film quickly and swiftly. So I'll leave that up to you. I'm not going to do it with you. If you come to tutoring, I'll do it with you, but I would encourage you to combine those all together into one. Alright, so that's only step 1. What's the next step? And if you do figure out the shortcut, it'll make that a little bit easier. What's the next step? We're going to look for a phase change here. So let's go back here. We'll look for our phase change. And remember, the rules for phase change is you're just looking at the indices, right? So if n1 is less than, if you go from a small to a large, there is a phase change. And if you go from a large to a small, there is not a phase change. So small to large there is, large to small there isn't. So let's just look at the two boundaries. So the first boundary is right here. So this is going from 1 to 1.8. So is there a phase change 1 to 1.8?
Yes.
Yes. You're going from small to large. So on this little boundary right here, I'm just going to write yes, phase change. Well, how much is a phase change when there is a phase change? 1/2. So yes, there is a 1/2 phase change because we went from 1 to 1.8, small to large, they're flips. Let's look at the second boundary. The second boundary is right here. This is going from 1.8 to 1.5. Is there a phase change there? No. So here we'll say no phase change. So if you want, you could write 0, but there's no phase change there. Okay, so that's kind of how you do it. So if I wrote this, I'd write PC1 equals lambda over 2. Phase change 2 equals 0. So what's my net phase change? Lambda over 2. So my net phase change is, there is a phase change, lambda over 2. And again, the concept of this is, here's our two waves. They come in the same, because it's the same wave. Then one flips like this at the first boundary. The second one stays the same at the second boundary. So when they come together, they're inverted. So one's going up, one's going down. And so to fix that, we're going to add that extra phase change back. And that's what we're going to do in our equation. So let's go ahead and do it. Let's find CI first. Remember, the equation for CI is 2t plus the phase change net equals 1, 2, or 3, or whatever. So just remember, like the concept of the last 3 days, when it's a full wavelength path difference, it's constructive. And then we're just going to account for the phase change. So when we do this, we're going to go 2t plus, there was a net phase change, that was 1/2. So So we're going to go 1/2 over 2, or lambda over 2, equals, now we want the smallest. The question said what's the smallest. So you just use the first one. That's the smallest. And then that's it. Do the math. Okay, so that would be 2t equals lambda over 2. And so t equals lambda over 4. And now which lambda do I use here? This is where people always make the mistake. They did all that work and then they use the wrong lambda. Is this the lambda in air or the lambda in the coding? Coding. So you do have to use the lambda in the coding. So we use, what was it? 334. .34 times 10 to the negative 7 divided by 4. It's like 8 point something.
8.3.
So this would be, this particular thickness would produce constructive interference. You'd see a bright, what was it, red? Bright red light. Okay, let's do DI. Almost the identical equation. What's the only difference? Lambda over 2, or 3 lambda over 2, or 5 lambda over 2. So let's write it out. 2t plus, there was a phase change, so we're going to go lambda over 2 here, equals, ooh, what happens here? Yeah, when we use lambda over 2, notice that that's 0. What do we do? Does that mean there is no possibility of destructive interference? You go up 1. So remember, these are all the different possibilities. So yeah, it doesn't work with this one, but it will work with this one. So this was going to be the smallest this time, not lambda over 2. Okay, do the math. You get 2t equals lambda, t equals lambda over 2. 334, 10 to the negative 7th divided by 2. How much is that? 1.67. 10 to the negative 7 meters. Okay? Alright, it's kind of tricky.